Okay, let's go and do the construction for transformations. So transformation means you have a shape and you're going to change into something else, do something with it. So first we're going to do the dilation. Let's go and do the enlargement. Okay. So again, if you start with a random triangle, okay, any shape, okay. And let's go ahead and make this as the center. Okay, I'm going to put a point right over here. Let's put right over here. Okay. So this is your center of the transformation. So first we're going to do enlargement. We're going to make this twice as big. Okay, the way to do that is, since this is a point of reference, okay, then what you want to do is go ahead and just draw this to every vertices. Okay, all the vertices. So you're going to draw. Okay. Then let's go and make the scale factor of 2. Okay. Let's make a scale factor equal to 2. Okay. So if it's 2, it's just going to double. So this is your one length, right? So scale of 2, you just go 1, 2. If it's scale 3 equal to 3, you go 1, 2, 3. Okay. So first, let's go and copy the length. Again, all this is just a matter of copying the length. Okay, so you get a length, right? So you go up here, that's 2. So that's scale factor of 2. Now if it's scale factor of 3, you just go 1, 2, 3. If its scale factor is 4, you go 1, 2, 3, 4. Okay? But just for the sake of space, we're just going to scale factor of 2. Okay? So 1, so that's 1, 2. And you do the same for all 3 vertices. Okay? So let's go and get the next one. Okay, right over here. So that's 1, 2. Okay, and actually this is kind of a bit off a little bit. Okay, and then let's go and do the third vertex. Okay, so that's 1, 2. Okay, and after you connect the 3 points, okay, so that's how you do the enlargement. Now to do the reduction, okay, let's go and do the scale factor of 1/2. Okay, 1/2 means you have to divide this by 2, right? Now, what happens is scale factor equal to 3. It's equal to 1/3. If the scale factor equal to 1/3, then you have to do this technique. Remember how to do this dividing by 3? So you have to divide each of these into like this. You have to do this for each of the 3 parts. Okay? See this over here? See, that's how you divide a segment, right? So for this, you have to do like this to get a 3 equal part, to get scale factor of 1/3. And you have to do that for all 3. Okay? But for the sake of time, we're just going to do 1/2. Because 1/2 is much easier to do. Because 1/2 you can just bisect, right? Bisect this length. Okay? So let's go and do that. Okay, so let's go and bisect this over here. Okay, and then from here, okay, so this is kind of off. Okay, so that is your first, that's your point over here. Okay, now we have to bisect this one here. Okay, since this is about the same length, I'm going to bisect this one next. Okay. Okay, so again, I'm going to do this. Do this. And then okay, so that's this point right over here. Okay, now to bisect these. So it's saying scale factor means you make each of these half, right? And half means bisect, right? Okay, so now that's going to do this one here. Okay, I'm going to make this bit bigger so it'll kind of be way out here. Okay. Okay. So from here, get this and this point right over here. Okay, and that would be the point right over here. Right, again, this you divide, you bisect, you get half, right? And so from here, you connect those three dots. Okay, so this is enlargement, this is reduction. Okay. Okay, next, let's go and do the translation. Okay, translation means you're sliding something over. Okay, so again, you start with a random triangle. Okay, and I'm going to slide straight down. Okay, so let's say if you want to, okay, so pick any reference point, okay, and you want to go from, you want to slide down by this much. I can just pick up any random distance, okay, so you want to slide down this much, okay. Okay, so what you need to do is, once you have this point, right? So what you want to do is, you want to slide everything down. So first you want to slide this length. Okay, so to slide this length, okay, what you need to do is you have to copy first. Let's go and copy the distance. Okay. Okay, so you can do it this way, same thing. Okay, so first we're going to copy the distance. Okay, so again from here, right, you copy the distance, so you move over to this point, and you're going to copy that distance. Okay, next we're going to copy this length over. Okay, so I'm going to move my hand out of the way. So right now you copy this distance and you move over here. Okay, and this would be your point. Okay, so from here again you copy this distance and you copy this distance, and that fixes that point. Okay, so now you have 2 points. Now to get this point, again, remember how to copy the triangle. Right, we did this earlier, right? So let's go and copy, let's go and draw this side first. Okay, so now we got this side copied, right? To get this one, okay, all we have to do is copy this length, right? Okay, so that's what we're going to do. Okay, so again, this go back to how to copy your triangle, right? Okay, so from here, okay, and copy this side over here. Okay. And once we get that, again, that's your triangle. Okay, so that's how you do the. Okay, so this is how you do the translation by sliding. So wherever you want it to slide to, okay, first you copy the distance and you copy the length, and then there you just copy the triangle. Okay. Okay, now let's go and do the, so this is translation. Okay, let's go and do the, something called the, so this is translation. Now let's go and do the reflection. Okay, reflection means flip things over. Okay. Okay, so again, let's go and start with a random triangle. Okay. And let's say you want to reflect over, again, I'm going to make a crooked on purpose, okay? Okay, you're going to reflect over the line, okay? Okay, so again, the way to do that first is you have to get a perpendicular, reflection, you have to get a perpendicular, just like a mirror, so you have to get a perpendicular line, okay? So what we need to do is, again, let's go and you find the perpendicular line through each of the point. Okay. And then from there, and then from here, you draw that. So that's your perpendicular. Now we have to get this distance, okay? So again, it's all about drawing the perpendicular line and copy the distance. Okay, let's go and copy this distance over here. Okay. Okay, so let's go and mark before we lose the spot. Okay, so this is equal to that. Okay. Okay, so next thing is we're going to do the same thing with this one here. Okay. We're going to do this, get a perpendicular line on this one. Okay, so you can get this reference point, okay, and then get this over here, get this reference point, get this over here, and from here you go straight down, okay. So again, what we do is just getting the perpendicular line, because when you're doing the reflection, you have to go perpendicular distance, okay, and now we're going to copy this length. Okay. Let's see. Okay. So that's you get your distance. So swing over. Okay. So that's your spot right over here. Okay. So I'm gonna connect these right away, so I don't lose track of what I'm doing. Okay. Now the third point, you can do exactly the same to get third point, or you can just copy the copy the triangle. So it's probably quicker if you just go and copy the triangle. Okay. So from here you can, okay, so you just copy that. So come over here. Okay, copy that. Okay, and copy this side. Okay, and that's your third point. And then from here you can just go and connect. Okay, so that's your reflection. Okay. Now, when you're doing a reflection, okay, that's what happens if you reflect over parallel lines. Okay, let's say if you have another line. Okay, I'm just gonna do. Okay. So you had, what if you, so this is a parallel lines, okay? So what if you reflect over the parallel lines, okay? Well, in this case, what you can do is, since this is perpendicular, and so this would be perpendicular already, so make things a lot easier, okay? So if you reflect over over two parallel lines, because they're parallel, so if this is right angle, this would be a right angle. So you already have nice lines already. So all you have to do is just go and get a distance already. Okay. So that's going to reflect this over here. That's going to measure the distance. So what we're doing is reflecting over two parallel lines. Okay. So that distance we give you right over here. Okay, so this is one reflection, and right now we're going to do second reflection. Okay, now this is two reflection over the parallel lines. Okay, so this is that point. Okay, then we're going to do the same for this one here. Okay. Okay, and that's the second point right over here. Okay, and now this distance, notice this is closer, so it's going to be right up here. So then you can just copy the distance. So we're going to copy this distance right over here. Okay. Now, how did you know it's over here? Well, you look at the distance, right? You know it's wrong over here because this distance does not equal to this distance. That's how you know it's up here, not down here. Okay? So you have to use a little bit of common sense to figure it out. Okay? So that's going to figure out this length over here. Okay. Okay, so when you reflect over two parallel lines, your result is translation. So two reflections equal to a translation. Okay, so again, if you reflect, it's same as sliding down. Okay, you can see that, right? So again, when you reflect over two parallel lines, you end up with a translation. Okay, it means you just sliding down. So we flip, it's same as sliding down. Okay, now what happens if the two lines are not parallel? What will happen? Okay. Okay, well, let's go and do the next one with two non-parallel lines. Okay. Okay. Okay, so again, we're going to start with a random triangle. Okay. And now we're going to reflect over two non-parallel lines. Okay, so you're going to have this line here, and I'm going to draw up lines that is not parallel. Okay, and let's see what will happen. So this one is you reflect over two parallel lines. You end up with a translation. So right now we're going to do the reflection over two non-parallel lines. Okay, so again, to do the reflection, let's go ahead and get the perpendicular line first. Okay. So make sure you know how to draw the perpendicular lines. Okay. So from here, you get that, right? And now we can go and copy the distance. Okay, so copy the distance. So I'm going to mark this spot right away so we don't lose that spot. Okay, then we're going to do the same thing for this one here. Okay, so again, we're just doing the perpendicular line construction from the basic construction. Okay. Okay, so from here you're gonna get this right over here. Okay, and again we're gonna get the distance next. Okay, so that's the distance, so we swing over to get that distance. Okay, so you can mark the spot right away so we don't lose that. Okay, so let's go ahead and connect that. Okay, so that's this reflect to here. So now to get that, again, you can do the same thing, or you can just copy the distance. Okay, copy the length. So I'm going to do copy the length method because it's a bit quicker and it's easier to do. Okay. Okay. So copy the length. You come over here. Okay, copy this length right over here. And I want to copy this length. So again, once you know your basic construction, all these are just combination of those basic constructions. Okay. So right now we're just copying the triangle, right? Okay, so you can go like this to get that length, and so come down here. Okay, and so that's the spot right over here. Okay. Now we're going to reflect over this line. So we turn a little bit sideways. So we're going to do exactly the same thing. Okay. And I'm going to use these 2 points. Okay. I'm going to use these 2 points because this one's kind of too close. So I'm going to use this and this. Okay. So you can pick any 2 random points, any 2 of the 3 points. Okay. So I'm going to use that. Okay. So again, I'm just drawing the perpendicular line. Okay, because when you're doing the reflection, it's a perpendicular line. Okay. And then from after that, I need to measure the distance. Okay, that, and then this one here. So you can mark the spot so we don't lose it. Okay. Then next I'm going to copy. I guess I can copy this one because it's closer. If it's closer, it's easier to do. Okay. So I can just use the same opening. Okay. So. Okay. can just use the same opening. Okay, there we go. Okay, so here's a point intersection. Connect to this point here. Okay. Then copy the distance next. Okay, put this right over here. Okay, copy the distance over. The disadvantage of when the radius is so small, it's kind of hard to do, so just be aware of that. Okay, so again, mark that spot. Okay, then go and connect that. Okay, now to get a third one, you can do that, or you can just copy the length. Okay, I'm going to just copy this length over here. Okay, so from this point to here, okay, let's go and copy that. Okay. Okay, so that's the length. So from here, we're going to copy this length. Okay, and then we're going to copy this length next. Okay, so from here, we're going to copy the length. Okay, so this is the dot. Okay, then just connect the 3 dots. Okay, that's how you do the reflection. Okay, now if this is confusing, to just go and do the same thing for this point, this point, and this point. Okay, now what did you notice is that what you have is that you have a rotation. Okay. Okay. So with this, right, what you have is a rotation. Okay. When you have reflection over 2 non-parallel lines, you end up with a rotation. Okay. So this point get rotated to here, this point get rotated to here, this point get rotated to here. Okay. Okay. So sum up. Okay. So when you have reflection over parallel lines, it's a translation. It's like sliding from here to here. Okay. When you have this is a rotation. So when you have a reflection over 2 non-parallel lines, you end up with a rotation. Okay. So basically, you're rotating the pictures like this. Okay. Okay. So that's what happened. Okay, and so that's it.